and welcome to our brand new web-based series, Design on Demand. I'm Matthew McMaster, and you're watching part 2 of our 4-part series on black chrome plating. We'll once again be joined by our 2 product managers, Jamie Stockton and Ryan Middlebrook. Today, they'll be discussing what low-temperature black chrome is, black chrome's advantages, and just how well black chrome holds up in corrosion tests. So let's go join Jamie and Ryan.
All right, so let's talk about what low-temperature black chrome is all about. First of all, I'm going to go through kind of a technical explanation about what low-temperature black chrome is, and then we'll get into some other aspects that'll also be very interesting. Basically, low-temperature black chrome is a ceramic-infused fluoropolymer-based plating solution applied at below 0 degrees Celsius, which is suitable for loaded rolling element contact. Through the plating process, an alloy-like diffusion layer is formed at the outer margin of the part, allowing particles to completely integrate the base material and create an inseparable bond.
That's quite the description there.
Right?
So what does that mean? I mean, it basically means that relative to a metallic plating solution, and because the core plate is a polymer base, as the shaft flexes or deflects with usage, that the plating solution, low temperature black chrome, is able to maintain its adherence to the steel surface over time, where a metallic solution will eventually crack and flake off. And that's really problematic, especially on a steel shaft, for example, because both the plating solution, in terms of the metallic plating solution, like a thin-dexed chrome or electroless nickel, looks about like the underlying shaft surface, right? So they're both metallic in color and shiny, and so you really don't notice that the actual plating system is failing until oxidation starts to occur. With cold black chrome, you actually are able to see the wear as the metallic subsurface starts to kind of shine through the black chrome plating. So it's visually easy to see when the product should be changed out of the application and replaced. So
That's great.
it's a real advantage.
Good. So we also did some investigation to figure out how well low-temperature black chrome holds up in a humidity and the salt spray type of environment. So what we did was we tested. We took a shaft similar to this one right here, and we put it into about a 95% environment of humidity, and it's in the 70-degree range. Much like it is in the Midwest right now. And we wanted to see how long it would last. So we were at 1,000 hours in a humidity environment like that, with the shaft just there in a test environment, and still didn't see any signs of corrosion on our low temperature black chrome shaft.
And that's with a 52100 carbon steel underlying material.
Well,
correct?
that's right. Yeah.
Yeah.
I mean, we've got the plating, as I described, right, infused into the carbon. So it's completely protected, and you don't have to worry about corrosion at all. So we were happy. Those were nice results, right? So then we did some salt spray testing. We'll kind of go into that in a little bit, but basically at 160 hours of salt spray, low temperature black chrome was still doing fine, which is great, because in a lot of applications on the coast, and maybe things that aren't even going to go on the coast, but the air comes in from the ocean and everything, it'll have salt content on it, and that's going to potentially allow for corrosion. So,
and salt spray is an easy way to kind of generally test anti-corrosive solutions as well.
Sure.
If you're going to put a product into a caustic washdown, for example, a lot of times viability you'll test with kind of that salt spray solution. So
right. And then, of course, how does this compare? How does low temperature black chrome compare to other products, like, let's say, 440C stainless?
Yeah.
And 440C stainless is something that's very commonly used in the linear industry, and I think in a lot of cases it's misused, because customer sees stainless steel on a product and they think, oh, it's stainless steel, I'm good. That's all I need. It's a stainless. It's not going to rust.
It's never going to rust.
Right. And you know, for folks that are watching that already know the answer to this, of course, that's not the case, because the 440 has a lot of carbon in it. So it allows us to harden the material so that it'll be a good surface for bearings and things like that. But it will rust, and it'll last a little bit longer than a
standard carbon
steel, but it's going to rust.
It's going to rust.
So in a lot of cases, doing something like a black chrome is going to be a much better solution than a stainless steel. So let's talk about this slide that we've got up now. It has it kind of goes through the different salt spray test results that we came up with, and as you can see on the left hand side, the 52-100 bearing steel, it starts out fine, and as we start with the salt spray, I think it's a 5% salt spray, right, in our test. At about 72 hours, you can see that there's visible rust, and it's not doing so well, the poor bearing steel. And at 168 hours, it basically looks like it's been on the bottom of the ocean for many years.
Absolutely.
It's pretty much rusted all the way through, and it goes that quick. And you can see with the 440 stainless steel, it holds out okay. I mean, it's doing all right. There's about half as much rust on it as there is the 52-100. So that just shows you in comparison, what you look at when you get a 440. And of course, there's our electroless nickel plating, which we haven't discussed at all yet today. But it seemed to be doing okay. It seems pretty much in good shape. And then you see the low temperature black chrome, which pretty much looks exactly like it did at the start of the test. 168 hours later.
And it's probably important to note as well that each one of these steel grades and plating systems have their own kind of core attributes that are beneficial. 52-100 carbon steel is great because it's hardenable, obviously, and it's got anti-corrosive alloys in it, namely chromium and manganese, which do facilitate better anti-corrosive properties than many other grades of comparable carbon steel. That said, if you're going to spray salt onto the unplated or unprotected steel surface, it's going to end up looking like my first car there. So that's not so good. Great. And 440 is obviously, as Jamie mentioned, a fairly anti-corrosive stainless steel, but it is able to be hardened, and because what enables that is the carbon content within the stainless steel. So ultimately it will rust. Nickel's great, frankly. Electroless nickel's great, but it is a softer material than what you might see in like a thin dense chrome or our cold low temperature black chrome, and therefore it's not really all that suitable for loaded rolling element contact. So ultimately, the most robust plating solution in the industry, as you can kind of see here, is our low temperature black chrome.
Well, and the nickel will crack.
Yes,
right. That's we talked about that on the previous slide. So that's the biggest problem, right? When it stresses and things like that, it cracks and then it starts to go away. Where the low temp black chrome isn't going to do that.
Thank you for joining us here at Design on Demand, and I hope you enjoyed part 2 of our 4-part series on black chrome plating. Join us again tomorrow for part 3, where Jamie and Ryan will discuss some various applications that black chrome can be used for, as well as discussing some various products that black chrome can be applied to. If you missed part 1 of this series, click on the thumbnail to my left to view that now. Also, check out our social media and our brand new blog, the MISUMI Mech Lab. You can find the links in the description below. If you like this or any of our other videos, please be sure to subscribe to our channel, as we'll be uploading tons of great new content in the weeks and months to come. Thanks again for joining us, and we hope to see you back.